topic is about resolution of vectors. So we know that the vector represents the quantity which has direction as well as the magnitude, which has some magnitude and also the direction. For example, if I am considering the force, so the force is a vector quantity and the unit of force is Newton. So now we are going to see about that resolution of vectors. So resolution of vector in the sense, let us consider the frame of reference as x-axis and the y-axis, and consider the force is acting in a direction and that makes an angle theta with respect to the positive x-axis. Now consider this as f vector. So it is making some angle with positive x-axis. Now what happens here? Here it includes both the axes, as the x as well as the y-axis. Now the projection of this force on the axis, that means projection is how much image of f vector is acting on the z axis. So this is known as the resolution. So I am splitting this vector in two axis. That means in y-axis how much projection of this vector is being on the y-axis as well as on the x-axis. So we'll just name that as the vector, I mean the f vector is having some projection on x-axis, we'll consider that as fx. This fx represents the projection of f vector on the x-axis, and this fy, so from origin to this height, we are having the projection of f vector on the y-axis. Now we know that, see, the height fy is same as here. So I am just taking a different color. So fy, so this is fy. So if this height is fy, this height is also fy. And now to determine the fx and fy with respect to f vector, now we know that the distance, I mean the magnitude of this vector can be represented as magnitude of f, which simply I can represent it as f. So just magnitude alone, not the direction. Now let us consider this distance as fx and here it as fy. Okay, so because the same height only will be on this side also, so I am considering it. So to calculate fx, so I have to consider the trigonometric ratios which includes fx as well as the hypotenuse. See, this will be the right angle triangle, and here the side opposite to theta, which is opposite side, and here it will be adjacent side, and here it is the hypotenuse. So the angle, the ratio which combines the fx as well as the f will be that cos theta, which is equal to adjacent side by hypotenuse. So adjacent is fx and hypotenuse side is f. So from here I can write fx, which is equal to f cos theta. And similarly the trigonometric ratio which combines fy as well as the fx, so that will be fy as well as the hypotenuse side, that will be sin theta, which is opposite side by hypotenuse, which is equal to fy divided by f. So from this I can calculate fy as f sin theta. So f cos theta and f sin theta can be termed as the components of the f vector. So normally a vector can be represented as, when it comes in the two dimension, that is the vector is having its things on x and y axis, that means in a plane, I can represent that as fx I cap plus fy j cap, which means I am having the component of f vector in the x axis, which means in the direction of I vector. So something in j vector. So instead of this fx, now I can like substitute this rectangular components, which is f cos theta I cap plus f sin theta j cap. So this f cos theta and f sin theta is known as the components of the vector f. This is known as the vector components of f. Now let us consider, if I am supposed to have like three dimensional, just instead of two dimensional, if it is 3D. Now see, in case of two dimensional, so let us consider x-axis and y-axis, and there is a vector here, consider that as f vector. So I just to find the angle, now let us consider the magnitude of f vector is f alone. Okay, so that means the magnitude of f vector, which is equal to f. Now if this f vector, consider it is making an angle alpha with respect to x-axis and it is making an angle beta with respect to y-axis. So to determine the angles of alpha and beta, that can be calculated using the direction cosines. So this is represented as C cos alpha. That means to calculate the angle alpha, that means with respect to positive x-axis, to calculate the angle made by this f vector with the positive x-axis, I can use the formula. So the projection on x-axis, which is in the sense fx divided by the magnitude of f. So this can be written as, so alpha, which is equal to cos inverse of f of x fx divided by modulus of x, which means the magnitude of force. Similarly, if I want to calculate the angle in which this vector is making with respect to y-axis, so I can have fy, that means the component along y-axis divided by the magnitude of the whole f vector. So from this I can calculate beta as cos inverse of fy divided by f. So this is in case of two dimensional. Suppose if I am having three dimensional, so one is along x-axis and y-axis and z-axis. So if I consider a vector, so this vector can make the angles with respective to all the axes. So consider it is making an alpha with respective x-axis and it is making beta with respective to y-axis, and with respect to z-axis it is making an angle gamma. So the same formula we will be using. But to find one more thing, to find f, see f vector, that can be represented as fx I cap plus fy j cap. So in case of 2D, I can find the modulus or magnitude of f vector as root of fx square plus fy square. Similarly, in case of three-dimensional, now we are going to derive it for three-dimensional. When I am jumping into three-dimensional, so I will be having cos alpha, cos beta and cos gamma. So if I consider cos alpha, so I just want to calculate the angle made by this vector with respect to x-axis, which means cos alpha, this can be written as fx divided by modulus of f vector. Okay, so from here I can write alpha is equal to fx divided by, alpha is equal to cos inverse of fx divided by modulus of x, which is f. Okay, and similarly in case of cos beta, which is equal to fy divided by modulus of f vector, from here I can write beta is equal to cos inverse of fy divided by f. So now we are having another angle, which is cos gamma, which is equal to fz divided by modulus of f vector. So gamma can be written as cos inverse of fz divided by f. So in case of three dimension, that means f vector can be represented as fx I cap plus fy j cap plus fz k cap. So here to find the modulus of f vector, which is equal to f, that is can be calculated by root of fx square plus fy square plus fz square. So now, so instead of these things, I can calculate alpha is equal to cos inverse of fx divided by root of fx square plus fy square plus fz square. So instead of this value f, I can substitute this modulus, that means the modulus of f vector. So from here I can also calculate, I'm just writing beta here down. Beta will be cos inverse of fy divided by root of fx square plus fy square plus fz square. Similarly, the gamma can be calculated as cos inverse of fz divided by root of fx square plus fy square plus fz square. So these were the formulas to represent or to find the angle made by this vector with respect to all the three axes alpha, beta and gamma. Similarly, a two-dimensional vector can be represented as f vector. If suppose this vector is having only two-dimensional, I can represent it as fx I cap plus fy j cap, that's it. But in case if this vector is having three-dimensional, I can write it as fx I cap plus fy j cap plus fz k cap. Similarly, this vector will have some projection on z axis also. So this is the way I can able to make the vector resolution. So now it is the direction of vector. So what gives the direction of vector? The direction of vector is being determined by the angle it is making with the respective reference line. So that reference line can be x-axis or it can be y-axis, it is whatever. But from respective to one reference line only we can determine the vector. That direction of vector is always determined by the angle it is making with respect to any of these reference lines. Now let us see the first condition in case of determining the angle of this vector. If suppose in case 1, if they are telling there is an a vector is making an angle 120 degree. So there is nothing given in this information, just they are telling that there is a vector, a vector is making an angle 120 degree. So when they didn't give about this reference line, we always consider the reference line as positive x-axis. So to represent this vector in graphical method, we have to draw the axis x-axis as well as y-axis. So as it is making an angle 120 degree, this 120 degree should be calculated from the positive x-axis. So positive x-axis, the 120 degree will be in this direction. So if I consider this as a vector, then it is making an angle of 120 degree. So this is the way we can represent the vector when there is no reference line is given. When there is no reference line given, we should always consider the positive x-axis as the reference line. Now, if we jump into the second case, for example, they are giving if a vector A makes an angle of 30 degree with the direction of east in anti-clockwise direction. Anti-clockwise direction. So in this case, first we have to make the directions like east, west, and here it will be north, and here it will be south. So they have given 30 degree with the direction of east. So I can either consider north as well as east, but they have given 30 degree with respect to east. We know that this north and east are 90 degree. Similarly, east and south are 90 degree, and south and west are 90 degree, north and west are 90 degree. But east and west is completely 180 degree, as well as the north and south is completely 180 degree. So when I compare that, east is nearer to this vector, right? The east, that means the 30 degree with east, in the sense I have to consider this east as the reference line of calculating the angle of the a vector, which means east should be considered as the reference line because it is the nearest perpendicular to this vector A. I can also consider north, but it is from this also I can calculate the angle of A vector, but as they said A vector is making 30 degree with east, so I should consider this reference as east, and I have to mention this 30 degree. In case if I am having a condition, this is not 80 degree, it is 30 degree. In case if I am having a condition that the A vector is making an angle of 70 degree with respect to east, so if I consider this case, see east and here it is north. So 70 degree means the A vector is nearer to north. So I can make that. So A vector is making like 70 degree. The total is 90 degree. If I reduce 70 degree, it will be 20 degree. So I can represent this A vector that it is making an angle of 20 degree with respect to north. So I can represent it. So which perpendicular direction is nearer to this vector, I can consider that perpendicular direction as the reference line for calculating the direction or angle of the A vector. Okay, and in case of and now in the third case, to find the theta, that means to find the angle between two vectors. Now let us consider A vector and B vector. The first condition is to make the two vector as co-initial vectors. So which means the two vectors should have the same starting point. Now let us consider if I am having A vector like this and I am having a B vector like this. So to calculate the angle between these two vectors, I should not calculate in this way. First step, I have to shift this vector where it touches, that means this tail touches the tail of the A vector. Now the tail of B vector is touching the head of A vector. So now what we have to do, we just first have to shift this vector to the tail of A vector without disturbing its orientation. So without disturbing its orientation, which means I'm just taking this vector and moving directly on this side. So if I move that vector, it will be coming like, if it is A vector, then B vector will be aligning in this direction. So now I have to consider this A vector as a reference line, and from here I have to calculate the angle between this B vector and A vector. Now let us consider it is making an angle of let us consider it is making an angle 70 degree. Now I can also calculate the angle in this direction, right? Because the complete direction is 360. If I am subtracting this 70, so this angle will be, I can also calculate it will be 290 degree. So this angle will be 290 and here it is 70. Now see here which angle I should consider. I should always consider the angle which is less than 180 degree or it can be equal to 180 degree. Now see here, this 290 is obviously greater than 180 degree, so I should not consider this. I should consider the angle 70 degree only, that is between A vector and B vector. So that is what, if suppose let us consider there is an A vector and here it is B vector. If it is making an angle of 120 degree and the angle on this side will be, it can be 240 degree, right? So yes, it will be 240 degree. So which angle I should consider? I should always consider the angle which is less than or equal to 180 degree. So 120 is lesser than 180 degree. So I have to consider the angle between A vector and B vector is 120 degree. So this is the way I have to find the angle between these two vectors.